previous class we have discussed your DFP method, that is Davidson-Fletcher-Powell method. In the previous class we have discussed this, and in this method we could see that we have some function, then we take some starting point, we have some B1 matrix, symmetric matrix, okay, and normally which is given in your problem, and which is a identity matrix, and then you calculate your gradient of function at your starting point, and accordingly you try to find the search direction and calculate the next possible or optimal point in that particular search direction. Okay, so initial these 3 points are going to be similar in the case of your today's discussion, that Braden-Fletcher Goldberg-Sano method, which is also known as BFGS method. Okay, so in this particular method, initial 3 steps that you need to calculate the gradient of function, you set iteration number I, you will be given the B matrix, that is symmetric matrix, okay, and after that you will set iteration number 1, and you will follow the steps like your previous method, that is PFP method. You will try to find the search direction, which will be given by Si equal to minus Bi into gradient of Fi. These steps are more or less similar to your previous method. Okay, then like previous method or other method which we have discussed previously, once you have identified your search direction, what you will do, you will try to calculate the optimal step length lambda I. Okay, so lambda I for iteration number 1, this will be lambda 1, and you will calculate lambda 1 in search direction S1. How you will calculate? You will set xi plus 1 equal to xi plus 1 lambda star, put the values in the function, and equate it by taking derivative of your function with respect to lambda equal to 0. Okay, so this process we have done repeatedly many times, so let us not elaborate much. Then fourth point is common, like previous step, you need to test your current point xi plus 1 for optimality. If the gradient of your function at the current point, that is xi plus 1, is less than equal to termination criteria, then you will stop. You will say that your current optimum point xi plus 1 is your optimum values of x. Otherwise, if it is not meeting the termination criteria, you will again go to the step 5, and what you will do in step 5, here you are going to update your Hessian matrix, that is B matrix. Okay, previously also in TFP some other formulation was proposed to calculate your B matrix. Here some other methodology had been proposed by these 4 researchers, so that's why this name is known as, the name of this method is known as BFGS method. Okay, so for calculating this BI or updating this Hessian matrix, we will use this formulation, that BI plus 1 is equal to BI plus this these particular terms. We will be taking what are these terms, GI, BI already we have calculated. How we calculate GI? It is written here that GI is equated by taking a difference between gradient of at current point subtracted by gradient at previous point. So this will be gradient Fi plus 1 minus gradient of Fi. And Ti is calculated xi plus 1 minus xi, which is equal to lambda I into Si. So these are the all terms which we need to calculate while implementing your BFGS method. Okay. Now what you will do, once you have calculated, you have updated B matrix, you will set your new iteration number as I equal to I plus 1. Suppose I equal to was 1 for iteration number 1. Then now you will go to the iteration number 2 and you will repeat the step, the whole process from the step number 2. That is, once you have identified new Hessian, new this B matrix, that is Hessian matrix, you will search there, try to find the search direction at x equal to 2. Okay, I hope you are able to understand, because more or less these methods were a kind of repetition, except a few steps like in DFP method we have changes in step number 5 only. Okay, so let us try to understand by implementing this particular method to the same problem which we are discussing from the starting. So the problem will remain the same, that is minimize function fx1 x2 which is equal to x1 minus x2. So the same problem we are continuing, starting from the point x1 equal to 0 0, using the BFGS method with given the value b1 equal to 1001 and the termination criteria epsilon equal to 0.01. Okay, so then we will start quickly like our previous method. We will calculate your gradient of function at x equal to 1. This process is same like your DFP method. We did this calculation in previous method also. Then we will calculate the search direction, which will be minus v1 gradient of f1. We have also calculated in previous problem also. Then we will calculate the value of lambda star using the same process which we have done, or we have implemented multiple times. Okay. Then we calculate the value of x2. Up to this point, you will find that all the calculations are same as with the example which we discussed yesterday. That is in the previous class for DFP method. Then we will check, once you have calculated x2, you will calculate the gradient of function at x2 and then check the termination criteria. Okay, so because termination criteria is not met, what we will do, we will try to update. Just a second. Okay, yes. So once the termination criteria, because the termination criteria is not met at x2, so we will proceed to update the Hessian matrix BI. So in order to update your Hessian matrix BI, there are a lot of terms which needs to be calculated. That is GI, DI, then only GI and DI needs to be calculated, then their transpose are involved. So here how we will calculate GI? GI is gradient of F2 minus some network lux is there. Okay, I hope my network is okay. So this G1 is equal to gradient of F2 minus F1. Okay, so this is given as this will come minus 2 0. Okay, then you need to calculate DI. So the DI is xi plus 1 minus xi, which is equal to lambda I into si. So you can write as d1 equal to lambda 1 into s1, or you can write it as x2 minus x1. Whatever you feel comfortable, you can do this calculation. This result will come the same. Okay, so d1 is minus 1 1. Then you need this term, that is a multiplication of d1 into transpose of d1. You can calculate this matrix will be 1 minus 1 minus 1 1. Then you need term in order to calculate your or update your Hessian matrix, that you need a transpose of P1 into G1, so this will be 2. Then all these terms which are needed in the complex calculation of your Hessian matrix Pi plus 1, we are only updating so that or we are calculating so that we can directly put these values inside this Hessian matrix. So you need to calculate D1 transpose of D1 into G1, then you need to calculate D1 into transpose of G1, then you need to calculate G1 into transpose of D1. So after calculating all these terms, you need to calculate these more terms. So all these terms are needed in order to update your Hessian matrix. And after calculating all these terms, you put these values in the updated Hessian matrix for calculating it. And if you put these values and solve it, you will get your next updated Hessian matrix is 1 by 2 minus 1 by 2 minus 1 by 2. So this is your value of B2, right? So once you have got the value of your updated Hessian matrix, what you will do? You will go to the step number 2. You will again go to the step number 2 and you will calculate or you will find the search direction at iteration I equal to 2. So how you will find the search direction? Search direction will be S2 equal to minus P2 into gradient of F2, right? So let us move. Yes. So for it, now we have set iteration number 2 and we are determining the next search direction, which is S2 equal to minus V2 into gradient of F2. Calculate this, solve this term, you will get 0, 2. Again, what you will do, once you have identified search direction, the process is clear that you need to calculate the optimum step length along the search direction S2. So this you will calculate, and this will this fx2 plus lambda 2 S2 will come 4 lambda 2 square minus 2 lambda minus 1. Take the derivative of this function with respect to lambda 2 and equate it equal to 0. You will get the value of lambda 2, which is equal to lambda 2 equal to 1 by 4. Then calculate the next point, that is, once you have identified your optimum step length in any such direction, what you can do, you can easily identify the next optimum point. So this will be x3 equal to x2 plus lambda 2 into s2. Put the values, solve it, minus 1 comma 1.5. So 3 by 2 means 1.5. So we can see, as we know the answer of this particular example through previous examples, so we know that we have reached the optimum point in only in 2 iteration. But if we are not knowing the optimum point, then how we will identify whether we have reached the optimum point or not? What you need to do, you will calculate the gradient of function at x equal to 3. So calculate the gradient of x function at x equal to 3. It is coming f3 equal to 0, 0. Take the modulus. If you take the modulus, it is also coming equal to 0. That is, it is less than your termination criteria. So since the termination criteria is met, you can say that you have find the optimum point for the given function. Okay, so this is all about your about the method BFGS, which was the last topic in your this module number 4. So from my side, I will stop here, and we can take questions. Not only technical questions, if there is any other doubt also in your mind, feel free to discuss from the module number 4, right?